Hey guys, welcome. We're going to go ahead and get started, and we're on 6.3. We have quite a bit of vocab today, but the vocab's pretty simple in this first section, so we're going to get right to it. And I'm going to actually have you not copy this down. We'll copy it all synthesized together. Okay, so our goal is to decide whether a quadrilateral is a parallelogram if its sides, angles, and diagonals have certain properties. That's kind of what we're focusing on today. So how can I tell if a quadrilateral is a parallelogram? So we're basically trying to prove any four-sided figure to be a parallelogram, and here's the way we're going to do it. So one, if both pairs of opposite sides of a quadrilateral are congruent, then it's a parallelogram. So if I have opposite sides congruent, we know it is a parallelogram. That's one way. Second way, so number two, if the angles of a quadrilateral are supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. So if B and A and D are supplementary, then we know it's a parallelogram. So that's the second way. Third way, if opposite angles are congruent, then I know it's a parallelogram. Okay, so that's our third way. Our fourth way, if bisecting diagonals, if the diagonals bisect one another, then we know it's a parallelogram. Okay, so that's 4 total ways so far. And our fifth way, this one's probably the weirdest one, because the other 4 we already knew. If a parallelogram is true, then that's true, so it kind of works like the converse. So this one states, if I know one side is congruent and parallel, then we know it's a parallelogram. Okay? So those are all the different ways. Now, here's where everything kind of is put into one spot. So if you want, I would write this down. So this is what you want to write, this right here. So this kind of saves us some time. So here we go. Prove that both sides, both pairs of sides are parallel. That's one way we can prove it. Prove both opposite sides are congruent. That's another way. Prove that the angle is supplementary to both consecutive. That's a third way. So that's 3 ways right there. Okay, so write that down. And then write this box down. So you really have to write these 2 boxes down. Prove that opposite angles are congruent. Draw the picture too on all of these. Prove that the diagonals bisect each other. And prove that one pair of opposite sides is congruent to one parallel. So you just have to write those 2 boxes, proving that a quadrilateral is a parallelogram. Saves us some time. Let's go ahead and look at a couple examples real quick. Here we go. Okay, can you prove that the quadrilateral is a parallelogram based upon the given information? Explain. Alright, well, let's go ahead and take a look at what we're looking at. So, here we go. It says, given AB equals 5, CD equals 5, AD equals 50, and D equals 130. Is ABCD a parallelogram? Approved so. Okay, well, first things first. We've proven that these are congruent. So we have congruent sides. I don't have 2 pairs of congruent sides, so I can't use that. But we notice that 50 and 130 makes 180. So these are same side interior, so using the converse of the same side interior theorem, I can actually prove that these 2 are parallel. And this was one of our rules, that we could prove a parallelogram to exist in a quadrilateral, that we have one set of congruent and parallel lines. So let's go ahead, I'm just going to walk it through that. We just discussed it, but this is what they went ahead and wrote down. So they went ahead and said, look at 50 plus 130. They're supplementary, so we know AB and CD are parallel. Okay, so we said that. They're same side interiors. So you're going to write this stuff down here. We know AB and CD are congruent, so ABCD is a parallelogram. We don't say theorem 612. We just say because one side, so one set of sides is congruent and parallel. Okay, and that's it. Very simple. Very, very simple. All right, let's go ahead and move on to the next question. All right. Can you prove that the quadrilateral is a parallelogram based upon the following given information? So EF is congruent to GD, so we have that marked, and DE is parallel to FG. Okay, can we prove it? Well, I don't have a theorem. If I could show DE and GF are parallel, I could do that. This one's going to be tricky. Let's go ahead and take a look at the correct answer. That's what I thought. We don't really have anything that fits up. So no, in order for it to be a parallelogram, one pair of sides must be both congruent and parallel. And we don't have that. So that was close, but not quite. Let's go ahead and move on to our last question for 6-3. Okay, here we have a real-life scenario. It says a truck sits on a platform of a vehicle lift. Two moving arms raise the platform, there it goes, until a mechanic can fit underneath. Why will the truck remain parallel to the ground as it's lifted? Explain. Well, if we take a look, and I'm going to actually push this back to right here. If we take a look, we have opposite sides are congruent. What that means is we have a parallelogram. So we can already state that Q, P, R, S is a parallelogram. Instead of writing parallelogram, we can actually write this kind of slanted quadrilateral looking thing. So we know this is a quadrilateral because opposite sides are congruent. And if opposite sides are congruent and this is a parallelogram, then we know these are parallel. Okay, so how do I know that the truck will always remain parallel to the ground? Because Q, P, R, S is a parallelogram. We can prove it. Okay? All right, well, that's enough for 6-3. Let's go ahead and jump over to 6-4. 6-4 introduces three new quadrilaterals: a rhombus, a rectangle, and a square. This is highly important that we write this all down. A rhombus is a parallelogram with four congruent sides. A rectangle is a parallelogram with four right angles. And then notice a square is a combination of the both. Okay, so it's a parallelogram with four congruent sides and four right angles. So it kind of has the best of all. There are some additional properties that we know about rhombuses. One of them is that their diagonals are perpendicular. So we always have perpendicular diagonals. 2, again, all these you're writing down. So sorry if I skip by that really fast. Go back and pause it. 2, diagonals also bisect the pairs of angles. So 1 and 2 are actually congruent. 3 and 4 are congruent. 5 and 6 are congruent. 7 and 8 are congruent. Okay? And write that down. And last but not least, we do have an additional rule about a rectangle, and it's that their diagonals are, whoa, I don't even know what I just did. I zoomed it in. How did I do that? Whoa, I could have been doing this whole time. Oh man, the irony. Okay, well, anywho, we could go ahead and see that the diagonals on this one are congruent, okay? And so we have a lot of information. We're going to try and synthesize this stuff next time we see each other. But let's go ahead and try some problems. So let's try our first problem, classifying a special polygon. So what kind of polygons are we looking at, and how do we figure it out? So first question is A, B, C, D, a rhombus, a rectangle, or a square. So it's kind of hard to see, actually. So I think if we scoot forward, it kind of makes it a little bit easier. So let's just pause it right there. I'm going to move my head out of the way. Alright, so it's A, B, C, D, a rhombus, a rectangle, or a square. Well, here's a dead giveaway. This little guy, that right there means it is a parallelogram. So we already know it's a parallelogram. So anything that's true of a parallelogram is going to be true of parallelogram A, B, C, D. So we know it's a parallelogram. And let's take a look at the picture. So we know that opposite sides are congruent. We got that. We know opposite sides are parallel. And if this is 90 degrees right here, angle B, then we know that angle, so here's 90, we know that this is also going to be 90 degrees. Opposite angles are congruent. So we know that this is a 90 degree right here. What we also know is that if this is 90, we need to have supplementary. Our consecutive angles are supplementary. So D and C have to add up to 180, and the only way they're going to do that is if they're both 90. And same with A. A and D have to add up to 180, so that has to be a 90. So A, B, C, D has all right angles. Their opposite sides are congruent, but they're not necessarily all congruent to each other, so I can't say it's a square. We don't have enough information for that. A rhombus doesn't necessarily have 90 degree angles, so I'm going to say it's probably not that. So the answer is a rectangle. So this is a rectangle. We can show that it has 90 degree angles. It is a parallelogram, and that's enough to say that it is good. Let's go ahead and look at one more of these. So we're looking at the same picture. This time we're looking at the parallelogram, or not the parallelogram, maybe just the shape on the inside. Okay, so let's take a look at some of our answer choices as I move my head away. And let's go ahead and go through these one at a time. Alright, let's go ahead and start at the top. It is a rhombus. Okay, so I'm looking at EFHG or EFGH. Is it a rhombus? Well, I see that there's two congruent sides, so it very well could be a rhombus. I'm not 100% sure. It says opposite sides of a parallelogram are congruent, so all sides of the GF are congruent. Well, it has the picture in front, so I do know it is a parallelogram, so that is true. So this is a true statement. I'm having trouble finding anything wrong with it, but maybe I missed something. And as I can see, there are no right angles, so it's probably not a rectangle. Let's see. It is a rectangle because there's 4 right angles. Well, I don't see any 90 degrees, so I'm going to go with this one is not true. B is not correct. C, it is a square. Opposite sides of a parallelogram are congruent to all sides. Well, that is true, but I would have to also have 90. Remember, squares have 90 degrees, and this does not. So, sorry, that doesn't work either. Not enough information. Well, since I know it's a parallelogram, I do know opposite sides are congruent, so all 4 sides are congruent. And a rhombus is, if I recall, a parallelogram with all congruent sides. So, I'm going to go with A as the correct answer. Let's see if I am correct. Boom! He's done it again. Yeah, that is correct. So this is a rhombus, we can tell. We have enough information on it. And let's go ahead and look at our last problem. I know. So quick that we just go ahead and... I'm sorry, this is not our last problem. This is our second to last problem. Okay. Ooh, this is a good one. What are the measures of the numbered angles? So we have 58 right here. Well, first things first, I know that angle 1 is 90 degrees. Yes, it is. Okay. We know that diagonals meet at what? They meet at 90 degrees. So all the diagonals of a rhombus, again, this is called a rhombus, meet at 90 degrees. So that's 90. Now, 58 and angle 2 are, well, if these are parallel lines, those are alternate interior angles. So angle 2 is equal to 58. 3 and 2. Remember, diagonals bisect the angle. So we know that angle 3 and angle 2 are congruent. By the way, what a horrible looking 2 that was. Let me try that again. Much better. So we know angle 3 is also 58. Okay, so we got all these angles solved for. The only one I don't know is 4, but I know I have a 90 and I have a 58. So if I add them together, I could solve. Let's get out the calculator. Okay, so I do 58 plus 90. So if I do that, 58 plus 90 is 148. If I take that away from 180, I think we're going to be doing good. Okay, and our final answer should be 32 degrees for angle 4. And that was using triangle sum theorem. Boom. Okay, so not too bad. Let's double check to make sure we got this right. So I'm actually just going to hit fast forward here. Boom, 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 boom. Okay, there we got diagonals. The diagonals of a rhombus are perpendicular, so that's 90. Good. And then, all right, angle 2, alternate interior angles theorem. I said that. Awesome. So that's 58. Good. Then we say each diagonal of a rhombus bisects a pair of opposite angles. So that's 58. Good. And then we can use triangle angle sum theorem. I said that. Oh my gosh. And all those angles add up, and we can find, did I get it? 32 degrees. Excellent. So make sure you have that written out. That looks beautiful. Whew, a work of art. Last problem now. I'm sorry if I led you astray. Last one. Here we go. Find diagonal length. We can do this. All right. In a rectangle, we have SF is 2x plus 15, and RB is 5x minus 12. What's the length of the diagonal? Huh. Remember, in a rectangle, diagonals are congruent. So SF is the whole diagonal. So guess what? It is going to be congruent. Let's go with black. I don't ever use black. So 2x plus 15 equals 5x. 1 second. Okay, I realized I went through this problem and accidentally paused it. So anyways, I'll recap. These two are congruent to each other. SF, this segment here, and RB, since we're talking about a rectangle, our diagonals are congruent, so that's why I set them equal to each other, and then I'm just kind of doing basic algebra, moving the 2x over, move the 12 over, so we get 3x equals 27 here, and then divide by 3, and we get x equals 9, okay? Now that's not my final answer. I'm going to box it for right now, but it's not my final answer. It says, what's the length of the diagonal? So I need to plug it back into one of these two equations. So I'm going to choose to plug it into the positive one. So 2 times 9 plus 15. And we can kind of do this one kind of in our head. 2 times 9 is going to be 18. 18 plus 15. I'm going to use a calculator so I don't make a mistake, even though I'm pretty sure it's 33. And I am correct. And we get 33 as our final length and our final answer. Alright guys, a lot of properties. Make sure you have them all written down. If not, go back or check them out in the book. I will see you later. Bye.